Hey, Vlad here, devinsidey.com, and welcome to 2018. This is the third video in the Scala playlist, and this is the first one where we actually get to play with Scala. Before we're starting to play with Scala though, I highly advise you to watch the first video in this playlist. Otherwise, you're going to think that this video is a bit weird. It is weird because I intend it to be weird. In fact, the way I'm going to teach you Scala is not the way I learned Scala, and in fact, it's not the way I learned any language. But I sort of wish that I had. Right. This is intended for absolute beginners, for someone who has never programmed Scala before, and in fact any other language before. And if you have, please try to turn your mind off and forget what you have learned so far. I hope you're as excited as I am. Let's get started. Alright, so I'm in Ubuntu in a virtual machine and I have an entire playlist of about how to set it up. And in the previous Scala video, we learned about SPT and we learned about how Java and Scala code compile down to the machine code. So we left off somewhere here. This is my Sublime, my text editor, and we had a folder called There's a First Time for Everything, and we had a folder Java stuff, SPT stuff, and so on. So what we're going to do now is we're going to ignore all of that. So instead what we're going to do is I'm going to go into the console, and let me put the console on the right, and let me put Sublime on the left. So I'm in my home folder now, and what I'm going to do is I'm going to create a folder called dav, and then I'm going to switch to dav, and inside of it I'm going to create a folder called video 3, right? And video 3 is going to be our project, so everything will happen in here. If I type in subl dot, a new instance of Sublime will pop up. The old one is still here, and let's close it. And now we have the new one. Okay, so we have an empty folder called video 3, and the first thing that we'll do is we're going to create another folder inside of it called project. And if you have seen my previous video, then you know that it has to exist, and it has to contain the file called build properties, where we set the version of SPT. So we say spt.version equals 0.13.6. There we go. What we also will do is we're going to create a file called build.spt, and we're just gonna set the version to 0.0.1 snapshot, and the Scala version, hold up, let me make that a bit smaller, Scala version to 2.12.4. And we're going to set the triggered message in this build to watched dot clear when triggered. All right, and that is it. That is all we need to do to get started. And let's actually create the first Scala file. Let's create a folder called source, and then another folder main, and then Scala, and then go in there. And in there, let's create a file called main.scala. Over here, we're going to have an object main with a def main args scenario of strings. And we're going to have a unit over here equals line hello world. And we're going to start SPT in that folder, because this is all that we need. And we're just going to say tilde run. And we don't need the sidebar over here, so I'm going to collapse it with Control KB. So now we see our hello world, and the way SPT is set up, if you haven't watched the previous video, tilde run will execute, will basically run our code every time we save the file. So if we say hi instead of hello world, I'm just going to save the file, and SPT is just going to rerun it. Alright, so I know I've already said a few words about how this video is structured, but I just want to repeat. So I want to have it as if we were sitting in the same room, and as if we were exploring Scala together for the first time, and hopefully discover a few treasures. So what we see over here is a print line hi. Actually, let's replace it with hello world again real quick. Hello world. All right, so I said it already in one of my previous videos that I haven't explained explained yet what that is, or what that is. But I've already said that everything between this curly brace and this curly brace is getting run. Okay, and again, we're not going to discuss this part yet, but what you can already notice is that those curly braces, they repeat, right? So there are some curly braces here, and there is some code over here. This code is it's a special entry point, so we can pretty much ignore it. But still, as of right now, just sort of understand that there's something special about those curly braces. And in fact, a few weeks ago, I made a video about lexical scopes, where we talked about boxes and elves. And if you have no idea what I'm talking about, maybe you should watch it. This is how you denote scopes in Scala. In fact, this is how you denote scopes in most languages. And the thing is that in only very few languages, and Scala is one of them, those scopes are a bit more evident. They're a bit more in your face, and this is what I like about Scala. So everything that has been in between of these curly braces is inside of that scope, or inside of that box, or inside of that elf. I know it's weird. Watch my other video. I'm sure it's gonna make sense, right? And also the same for here. Everything in that scope is also running in one way or the other. But as I already said probably 3 times, we're not going to talk about that. In fact, editors, they even have a shortcut to understand scopes. I believe in Sublime it's Control-Shift-Space. Hold on. So I'm going to have my cursor here. Let's see, a Control-Shift-Space. Yeah. So it understands that this is a scope, and then that this is a scope, and it just keeps going like this. See, that's exactly what I just explained. And so an editor that does not understand any bytecode, does not understand any machine code, it's still even on the syntactical level, it understands scopes. Now, I just talked about scopes for a few minutes already, but I haven't really defined what scopes are, and in fact I'm not really going to. All we need to understand now is that all the code in the scope is just going to run top to bottom. So what's going to happen if we're just going to press enter here and say print line something else, right? And this is what's going to happen: hello world and something else. So you should feel like every line is running from top to bottom. We will actually discuss it in still in this video, but it's actually not the line that matters, but it's actually scopes. Like right now you don't really see it, but what's happening is that this is a scope, and this is also a scope. So basically we have scopes inside of scopes, and they're running top to bottom. The first thing that we're going to do, we're going to say over here that this is the line 3. So we're going to pretend like we're not running scopes. We're going to pretend like we're running lines. Okay, so line 3 and line 4. So what is going to happen if we do this? We put this print line into a separate scope like that. What's going to happen? Well, first of all, this is not a line 4 anymore, it's line 6. But as you can see, Scala doesn't really care that it's in a separate scope, and we're gonna talk about this a little bit more in detail. But basically, whenever there's one thing in a scope, then sometimes you can leave the brackets out, and this is basically what's happening over here. Also, we haven't really talked about what print line is, but print line is a box of its own, or a scope of its own. So it's a special one because I haven't explained it yet, because it's a special one because we can actually inject something into that scope. So we can put something into that scope, and in fact over here this is what we're putting in there. And we're going to talk about this a bit more in depth later, but line 3 again is also a scope. So if we just surround it with curly braces, and it's not going to change anything, right? And we can also have new lines here, and they will also be ignored. They're not always ignored. There are some very special rules, but we're not going to talk about them now. Let me revert that for a sec. So we have line 3, line 6, and let's add a few more. So what do we have here? We have line 9, And let's do one more of these over here. It's line 12. And one more of the regular ones. Line 15. And let's see what happens. As expected. Notice again that most of the times empty lines and spaces are ignored. So if we had a line here, and had a line here, I mean, obviously the value here changes. So this is now line 13, and this is line 17, but the compiler doesn't really care about it. Okay, so we just see everything like that. Since we're already, since I'm already introducing Scala, I might as well mention comments. So if I just have some random text somewhere here, then if I started with double front slash, then the compiler will ignore everything until the end of that line. So if I have actually valid code over here, print line 11, the compiler will ignore that. See that? See, there's no 11, there's only 9, and there's 13. It might not be evident right now, but in the future you might want to have a comment inside of the line, somewhere like in between. And the way you do this is by having a forward slash and a star, and then closing it as well with a star and a forward slash. And then after that, the compiler will still evaluate that. Now, this is obviously not a valid Scala syntax, therefore it will not compile. But as I just mentioned, as of right now, it's not really obvious why we would need that. But in the future, probably even still in this video, it might be evident why we would want something like that. All right, let me revert that. Revert that. And we're back to that. One more thing, notice that in this scope right now, we have multiple things, and we could have had the same in any other scope. So for example, over here, we could have said print line 12. And it might sound boring so far, but this is really so fundamental that I decided to dedicate almost entire video to that. In fact, the previous video about scopes and boxes and elves, it might have seemed completely random, completely out of sequence. But again, I just think that it's so fundamental if you understand this idea of thinking in terms of scopes, then the rest of Scala and probably the rest of programming is just going to make sense. There's actually a computer science term behind it, but I'm not going to mention it here. Let me remove the line 12 now. All right. Okay. Now the next thing that we're going to talk about, and again, it's still going to be about scopes. Probably this whole video is about scopes. There are two things that we don't really like about that. The first thing is we need a way to write big programs, right? Programs that are separated into hundreds and maybe thousands of files, okay? And the second problem is that we don't want the flow of control. This execution of those lines is called the flow of control. So as of right now, the flow of control is just top to bottom. We don't want the flow of control to align with the basically with the syntax of the language. So only because this scope, for example, is written over here, does not mean that it should be evaluated over here, right? We might just want to store a computation somewhere and just run it later, maybe run it multiple times. The way we solve both of these problems is called assignment. The idea is basically just to give names to scopes. And in English, what you might be interested in doing is to say, okay, this scope is called line 6 or something. Now, programming, the beginning of programming had something to do with math, and even though most programming languages have even though a lot of programming languages have different syntax for assignment, most programming languages they just use an equal sign. So it would look something like that. So this scope is called line 6. This is how you would write it. Now, first of all, don't confuse this with math, right? Programming is not math. So in programming, A equals B is not the same as B equals A. And also, only because the symbol looks like an equal sign, in this case, it does not mean that. It means assign whatever is line 6 into that scope. And because of the way I just said this, it should sound completely confusing, because I tried to do that really confusing on purpose, because I wanted to drive the point home that this is not how programmers think. This is not how computer scientists think. When a programmer wants to give a name to a scope, what he understands is that what's happening behind the scenes is that the scope somehow is stored in memory, and therefore the direction is basically on its head. So we don't want to say that this scope is line 6. We want to say take this scope and assign it to line 6, and therefore we write it this way. We have line 6 over here, and we have an equal sign over here and over here. Right? And notice that I haven't even tried to compile this the whole time. I was just talking and just writing something, right? Because this is so-called pseudocode, so this was not really Scala code. Right now, it's almost Scala code. Like if this was Python, something like this would actually work. In Scala, you have to have a special keyword to introduce assignment, and also to say that we don't want to change the flow of control. And this keyword is val, and it stands for value. So if you just have val over here, see, Sublime understands that. So if I run this program now, nothing is going to change in terms of the effects that we see over here. It still will say line 3, line 6, line 9, line 13, and line 17. In fact, let's do that. See, nothing changed. But at a later point in time, we can refer to line 6. Okay? So first of all, let's write vowels over here, and over here, and over here, and over here. So I'm going to say vowel, and I'm going to say line, and I'm going to have an equal sign over here. And because we're in the same scope, we can't call them the same. We can't call them with the same string. So this one I'm going to call line 3. This one is going to be line 9. This one is going to be line 13, and this one is going to be line 17, and nothing's changed. Okay. And also notice that the compiler has some special restrictions for the names. So because this is the first time where we actually introduce sort of like our own keywords into the language, and therefore there are some limitations. And in Scala, a name can begin with any letter. Usually it's a small letter, or some special symbols. In fact, most of the symbols are valid, but not numbers. So a vowel cannot start with a number. So if I have a 3 over here, for example, whoops, I'm sorry, 3, it's going to say illegal start of simple pattern. Okay, that's actually not helpful, but it's an error, as you can see. I think one of my neighbors is vacuum cleaning now, so apologies for that. I hope my microphone is not sensitive enough to hear that. All right, so we have those 5 vowels, and with their help, we introduce names, right? So we have line 3, line 6, line 9, line 13, and line 17. So basically, we can refer to those scopes by name, right? And this solves these 2 issues that I mentioned a few minutes ago. So now, if we had some code in another file, which is not something that we're gonna concern ourselves with today, but we would at least be able to reference the scope by the name of line 6. So as of right now, we're just gonna stay, basically the whole video, we're gonna stay inside of this scope. All right, so what we're gonna do here is we're going to go under line 17. And because we can refer to this scope by name, we're going to print out this. Let's see what happens. So we're going to print out line 3. And we're going to do the same with 6, 9, 13, 17, right? So we have 5 of them, 6, 9, 13, and 17. All right, so now you should be really confused, okay? Because it felt like we have line 3, line 6, line 9, line 13, line 17. And I said that, well, using these names, we can refer to this code later. But in fact, what happened now is once we actually refer to that, we see this, right? So before we continue, and before I explain that, let me just comment out all of that. And let me comment out all of that, so that we can just play with line 3. So let's see what happens. Okay, so we have line 3, and we have this thing. So what happens is that, remember I said that this is a scope and there's some code in that scope. And remember I said that when we introduce the name, we use the keyword vowel to not change the flow of control. So because we use the keyword vowel, the code is still executed top to bottom. I know you might have expected that it would execute twice, but it hasn't, because the flow of control didn't change. So over here, this line has already been executed once the compiler reached line 4, right? And by the time it reached line 13, it tried to reference this code over here, but it already ran. So what came back was this. And it turns out that this is just a different syntax for that. So I'm printing out that is basically the same as printing out line 3, as you can see over here, right? I'm not sure why I didn't have a new line over there. Maybe this is a good point in time to show you what is going to happen if we have, oh yeah, yeah. So because I didn't say print line, I just said print. It didn't have the new line. Why didn't I have that? Kind of silly. All right, there we go. And also notice that if you don't even have that, if you just have a print line without anything, don't confuse this with scopes. This is just a syntactical thing here. Then it will actually have an entire empty line over here, like that. In fact, maybe we should start our program with an empty line. Let's start our program with an empty line, and then move this a bit down, and let's say that this is line 5, and the variable is also called line 5. Okay, in fact, you know what? We don't really need these anymore. Okay. So we have the empty line, which comes from here. Then we have the line 5 over here, which comes from this whole line. Then we have this, which gives us this scope here. And then we have that, which gives us this scope here. And then we have just an empty line. In fact, let me press enter over here so that it's visible that this whole thing is our program. In fact, you know what we should do right now, since we're sort of narrowing down our scope, this is a bit more visible, right? So we're always going to have this print line and this print line. So from now on, our code, we don't concern ourselves with the whole thing. We just concern ourselves with this. And we also move to line 6, 6, and 6 over here. Okay. So as you might imagine, there are other keywords that actually change the flow of control, and we're going to talk about them in a few minutes. Before that, we're going to talk about this. So remember when I said that when we give names to scopes, or the other way around, we actually assign scopes to names, that we're actually storing something in memory. So what are we actually storing in memory? And it seems that the answer is nothing useful. So whenever we have something like that, then the value of that code is a so-called side effect, right? Because the effect of that code, we can't store it in this variable. So because it just kind of happened already, and we're left with an empty scope. Now, as I said already, we're going to have a few other keywords that will actually help us to capture those side effects in a way that we can repeat them. But still, no magical keyword will all of a sudden produce a value out of an empty scope like that. Okay, so before we continue, let me remove that because we don't really need that. Because I want you to focus on, okay, we have line 6 and we're printing it out over here. Okay, so how do we actually produce a valuable value? It turns out that all we need to do is we need to take this, and the first thing that we do is we need to surround it with a scope. And Sublime and a lot of other editors, as I said, they already understand scope. So if I mark a piece of code that looks like a scope anyway, and in fact I can do this with Control-Shift-Space that I already said, this one and this one and this one. Now that's actually too much. It doesn't understand that this is a scope as well, or it doesn't understand that I want it to be a scope, right? So if I press the opening curly brace button on my keyboard, that what it will actually do is it will also put a closing curly brace in the end. And it will do the same thing with these braces. It will also do the same with quotations, and also with single quotes, I believe, and also rectangular brackets, and so on. Okay, but in this case we need that. And what we do now is we want to produce a value. What value do we want to produce? Well, let's just do something simple. Let's produce a number. And the way we produce a number is by saying semicolon, and then what we want to produce, 1337. So now what will happen is we see line 6, which happens at line 6. But once we reach line 8, we actually see 1337. So remember in the beginning, I said that it looks like we're concerned with lines, but in fact we're concerned with scopes. And this is the evidence that you see over here. So now we have two things in one line, and the way we separate them is with semicolons. And in fact, it's very untypical in Scala to do that. What we would usually do is, first of all, we're going to inline our scope properly, right? So first of all, this is already at line 7. Right, let's rename that. We don't have to rename that. I'm just renaming it for clarity so that you're not confused. So when we run it, the same thing is happening. And what you would then do is you would just put the next thing on the new line, and therefore it looks like the compiler is concerned with lines, but it's actually concerned with scopes. All right. So what is going to happen if we actually switch line 7 and line 8? You might have guessed that this would happen, right? Because it's the same as saying 1337, then semicolon, and print line 7, right? It should be exactly the same code. Let me revert it real quick. So what is happening here, that if you want to produce a value, then the last line or the last statement is the one that produces the value out of scope, right? So we could have print line, useless again, and then we can say line 9, and all of that is going to run. And usually it's sort of like a convention, or this is the thing that I like to do, basically to have an empty line here, just so that you can see in this scope the last thing that is happening is this, and this is what is returned and saved into line 7. Okay, so let's run it, and we see useless again, we see line 9, we don't see that. We only see that once we reach line 14. In fact, let me do this. I'm not going to explain that syntax yet, but we can do this. Line, let me just say last print line, and then, whoops, sorry, and then have that. Okay, so that you can see that the 1337 is printed out over here, right? Not over here. The next thing that you need to know about Scala is, look at this statement, for example, over here. Remember, everything is a scope, so having that is the same as not having that. Okay, so the rule is that if there's only one thing in the scope, as I said before, then most of the times you can leave out the curly braces. In fact, over here, whenever you want to assign the scope to something, and there's only one thing in the scope, and this thing is called an expression, by the way, then you can also leave out the curly braces. Right? So if I leave them out now, something weird will happen. Right? So what happened was, it thought that line 7 has the value of useless, and the value of useless is an empty scope, right? Which is why in the very end, we said last print line is an empty scope over here, right? Then it just printed out that, and then it warned us that a pure expression does nothing in statement position, right? So because we have an expression over here, an expression is something that a program can turn into a value, okay? And usually the reason to evaluate an expression is to assign it to something, and in this case we're not assigning it to anything, and therefore this is not a position in which an expression is valid or useful, and therefore it's a statement position, right? It thinks that it's a statement position. So this is a statement. A statement is something that produces a side effect, basically, and this is an expression. Expression always evaluates to something that you want to store somewhere, right? So basically, what I wanted to show you that, first of all, curly braces are important, and understanding scopes is important. And second of all, if you have only one thing, in that scope, like that, then you can leave out the curly braces. And in fact, you could write them in one line. And now, all of a sudden, it looks like a variable in any other language. Okay, so now we're going to talk about the other keywords. So there's not only val, there are also others. There are two main ones. One is called val, and the other one is called def. So val stands for value, and def stands for definition. So first of all, let me introduce the scope peg again. And let's actually have, oh, by the way, it's line, let's not call it line 7 now. Let's call it my favorite number. By the way, this is called a camel notation, where every new word in a variable starts with a capital letter. And some camel notations also start with a capital letter. But in Scala, it's a convention to start them with a small letter. Okay, so we have my favorite number, and the first thing that is going to happen is going to be print line 7. Okay, and we're going to see in a second why this is useful. I'm going to repeat myself. In the beginning, I said that there are two problems that we want to solve. The first one is we want to reference pieces of code from other files, and we'll sort of solve that, right? Just create those names, use the keyword val, and in a second you will learn how to use other keywords. But basically, names, right? Names allow you to reference code. And the other part was to change the flow of control, right? We want to detach the execution of that scope from its definition. So it's defined over here. It doesn't mean that we want it to run over here. The way it's done in Scala is simply by saying def, right? So now because it's a def, what is happening is that the scope is referenced by my favorite number, but it is not going to run at line 6, right? So what will happen is that we will see this first. In fact, let's just run it first. Let's just run it. Now, you see exactly the same thing. I know you were hoping for something special because of the way I explained it. But in fact, in order to see that, we would need to print it out twice. We would need to access this scope twice. And before we do that, let me change it back to val. Remember when we had 5 of them? I already did that, but just as a refresher. So I'm going to change it to val. And I'm just going to do this. And I'm going to say over here, first time. And over here, I'm going to say second time, right? In fact, let me have here, I'm running at line 7. Okay, so I'm running at line 7. And before I'm going to switch to def again, let's trace it properly. How what is actually happening, right? So when the compiler is here, right, it sees that it's a val, and therefore it knows it needs to run this scope right away. Therefore, the first thing that we see is print line, right? This is the first thing that we see. Then this thing, it does not get printed to the console, right? It just gets returned and assigned to that variable. Then it just keeps going. So it's done with this thing. Then it goes here. It goes to that scope, and it just prints out that. It goes to this. It goes to here and sees, okay, it was a val, therefore it's already ran, therefore it just accesses the value directly because it's stored it, right? And therefore we see first time 1337. And then the second time, exactly the same thing is happening, right? It goes to this variable to see, hey, it already has been executed, and therefore it just accesses the value 1337, in this case, straight from memory. So when we change this to a def, something different will happen. Right? So what's happening now is that exactly the same effect is happening twice, right? So we see I'm running at line 7, first time 1337, then I'm running at line 7, second time 1337. So what happened is when the compiler saw the def here, so it went straight from 1, 2, 3, 4, 5, 6, then it saw a def. And then it knew that all it needs to store is not the reference to that value. What it stores is the reference to this entire scope, okay? So it doesn't run it. Notice that it doesn't run it. So if we remove print lines, and if we have a val, or val, then it actually runs it. But if we have a def, then it doesn't run it, right? So in fact, we get a warning. Again, a pure expression, blah, blah, blah. So it talks about this whole thing, and it thinks that it's an expression in the statement position. Okay, so it warns us about this whole scope. Okay, So if you have a vowel and we run it 2 times, we see this, and if we have a def and we run it 2 times, we see that. So let's trace it back. So when it's at line 6, it doesn't store the value of 1 through 7 into the def. It stores the whole scope, and therefore once it reaches this, it tries to print out first time, and then to get this value out of memory. But the problem is that what's in memory is not 1 through 7. What's in memory is the scope. So this is the first time it runs this, and therefore this is happening before this, the same as before. Remember, this is why when we had to print it out once, you couldn't even see the difference between a val and a def. But the second time we're running it, it would like to access this this variable to retrieve it straight from memory. But again, the same thing is happening. The value is not in memory, only the computation is in memory. So what it's doing, it runs it again. All right, so the next keyword that we're going to we're going to talk about is something in between the val and the def. Okay, and it's a keyword that comes from functional programming, a topic that we will discuss in one of my future videos. And so it looks like a vowel, but it's actually not a vowel, it's a lazy vowel. Now, in order to see how lazy vowel is different from val and a def, we will need to remove those print lines. And as I already said, lazy vowel is a mixture between a val and a def. So the first time it behaves like a def, and all the other times it behaves like a val, which means, let's remove the print lines. Let's have a def over here. Run the program. Nothing's happening. Let's have a lazy vowel. Nothing's happening, but this time the compiler is not complaining. But we're going to ignore that for now. It doesn't really matter for now. But as you can see, the first time it's running, it behaves like a def. And for a def, you can also say that this here did not even run once, because remember, def it does not even run unless you reference it. So let's turn it back to a def real quick and have one print line. Okay, this is how a def behaved. So the first time nothing happened, which you can't see here, but then something did happen. And the same thing for a lazy vowel. Lazy vowel, right. For a def, however, def ran twice, right? It ran twice, the whole thing exactly the same. But for a lazy vowel, the second time it ran, it started to behaving like a vowel. So let's trace this code back. Okay, so when the compiler reaches the line 6, it sees that it's a lazy vowel, right? So it remembers the computation the same way as a def would do, but it doesn't run it until, and therefore it's called lazy, until we use it for the first time. So over here, it was actually used for the first time. Therefore, this computation ran once, but after it ran once, it actually took the 1 through 7 and stored in that vowel. Okay, and therefore the second time we exited, the second time we accessed the my favorite number, we did not see this print line, right? Because this computation did not happen again because this value was already in memory. Therefore, we don't see this line between first time and the second time. Now, the last keyword that we're going to discuss is the keyword that we're going to discuss the least in the entire playlist. It's a very dangerous one, and it's called a var. And it stands for variable. So instead of having a vowel or val, we're going to have a var. And you know what? Let me write down everything that we had so far. So val is a value stored in memory. Def is a definition. Only the computation is stored. There we go. And then we have a lazy vowel. Behaves the first time like a def and like a vowel afterwards. I don't really need a comma here, right? And now we're also going to have a var. And a var is, I think that is most common actually in programming, unfortunately. A var allows you at a later point in the lifetime of a program, so at a later point in time, forget this scope and assign a completely different scope to that variable, right? So in terms of control flow, it behaves like a vowel, right? So you won't actually see the difference over here. Let me remove the print lines. So as soon as the compiler touches it, it executes it. Therefore, we're going to see that, and therefore we're not going to see I'm running at line 7 again. But what we can have now is, instead of saying var, my favorite number again, we're going to leave the var out, right? And we're going to, the rest of the syntax stays the same, right? So we're going to have, whoops, sorry. We're going to have a print line, I'm running at line 16, and so now it's 7331. I just reversed it. Doesn't really matter. So what's going to happen right now? Actually, nothing really visible except for that, right? So the flow of control is still the same, right? Even though there is no keyboard, this is happening right when the compiler reaches that point, right? But then later, if we do third time over here, print line third time, we're actually going to see 7331. And this keyword is very dangerous, as I already mentioned, and it's actually kind of frowned upon these days in programming language communities. Yeah, so basically, as a beginner, just don't use it for now. All the beginner problems that you should be exposed to don't really require the var keyword. Also, I didn't really plan on talking about this in this video, but understand that you have to introduce the variable first, right? You have to introduce the value or the definition or even a lazy vowel. In fact, lazy vowel an exception before you use it. So over here, it's introduced over here, and only then it's used, right? Or it's introduced over here and only then it's used. It's introduced over here and only then a new value is assigned to it, right? Because of that, basically this makes vars even more dangerous, right? Because with a vowel, it's sort of obvious, right, that you have to have this variable before you start using it. But with a var, it's sort of not obvious, right? Like look over here. So over here, we assigned a different value to my favorite number, okay? But before that, we actually printed out my favorite number. Now, of course, it had a different value, but from a mathematical point of view, there's no way to know that at this point in time the value was different. Like right now, we see the whole program. It's just a few lines, so we see the whole program in one file at once. So now we know. But imagine having hundreds of files, right? And then you're accessing the variable, right? And you don't know which value it's going to have, right? So this is why vars are kind of dangerous. But since I'm already talking about this, look what's going to happen. Let's revert actually that. Let's revert that. Okay. Let's just have only the first time. Okay. So if it's a vowel and print line is over here, what's going to happen if we have print line over here? Right. So I just moved the line up. What's going to happen? This variable doesn't exist here yet. Right, so it's only introduced over here. So what is the compiler going to do once it sees that? Right, it's not going to just keep looking for it. Right, what's going to happen is it's called forward reference extends over definition of value my favorite number. And this is one of the reasons why I'm showing you this, because you might think, oh my God, is the compiler stupid? Why can't it actually tell me what's happening? In fact, it's a really hard thing to do from a compiler point of view. It doesn't see the whole program at once. It sort of sees it letter for letter. So it knows that something is happening that it didn't accept, but it doesn't exactly know what went wrong. Okay, so it can't actually tell you with human words what went wrong. Some compilers are better at this. Some compilers are worse at this. Yeah. So basically, what it's telling you at this stage, I don't know this. Now notice that with a def, not the same thing is going to happen, right? So with a def, it's going to do that. And in fact, now I'm realizing that I should not have introduced you to this because it is actually confusing. So just know that for def, different rules apply, and also for lazy vowel as well. Lazy vowel, all right? Should be the same, okay? The only thing that I'm going to say about this is that it gives you even a further tool to sort of mess around with the flow of control, right? So it gives you another way of decoupling the syntactical structure of the program from actually the execution sequence. This is also one of the reasons why languages like Scala or Java or C# that they're not scripting languages, because one of the main things, at least for me, to differentiate a scripting language from a full-blown programming language is that scripting languages, they're really good at running just top to bottom, right? I'm not saying that this is all that they can do, but they're just really good at that. And programming, like regular programming languages, they're much better at giving the programmer the control over the plan of execution, basically over the control flow. Another thing, notice that, and this is a bit specific to Scala, Scala does not betray. When you look at a variable, it doesn't betray if the calculation of that scope happened from memory or if it happened by computation, right? So if later, if somewhere over here we have a print line, right? If I just look at that, right? So if this code was not visible, if this was somewhere in a different file, you would not know that this favored number, like you would not know based on syntax that it's a vowel or it's a lazy vowel or it's a daf. Now this obviously has advantages, but it also has disadvantages, right? In fact, this thing has a name, and it's called I believe it's called the uniform access of control. All right, so it's actually called uniform access principle, and it says that, let me zoom in a little bit. All services offered by a module should be available through a uniform notation, which does not betray whether they're implemented through storage or through computation. So basically, there's no way to differentiate a vowel from a daf and from a lazy vowel. And now this is actually a concern, and it is not only an advantage. But I've been programming in Scala for 7 years, and this only rarely caused some issues, right? So usually what you would do is you would just call your variables properly, right? So if this is a daf, for example, right, you would call this something like calculate my favorite number, right? But if it's a vowel, you would just say my favorite number, okay? And most of the time this is enough. So last thing, let me finish this. So var is like a value. Actually, it's a variable stored in memory, like val, but can be reassigned. In fact, one of the last things that I'm going to do is I'm going to say that when you introduce a variable and right at the spot you assign a scope to it, then this is called initialization, and it's also called binding. It is sometimes called definition, right? And in the computer, in the programming circles, whenever later, if it's an actual variable and you're actually sort of reassigning a different value to it, right, 3771, then this is usually what's called assignment, right? So this is not assignment, this is initialization or binding or definition, and this is assignment. But the way that I used it in this video was I said we assign this scope to this variable, and over here I said that we're going to reassign what is assigned to that variable. All right, we finally arrived in the end, and I'm really trying to get this video shorter, but I just can't. I hope it wasn't too confusing. Let me know what I can do better next time. And I hope one of your New Year's resolutions is to learn Scala. And I hope I did not ruin that resolution. All right, well, have fun. Take care. See you next week.